For my chemistry semester project, I chose to do the compound calcium chloride, and I chose it because I just wanted to do a simple compound, something that we learned about before, and also a compound that has many different uses, like calcium chloride. So, the chemical name for calcium chloride is CaCl2, the chemical formula, and its structure, as you can see here, the Ca, the calcium, is the central atom, and it has double bonds between the Ca and both Cls. And since it only has two bonding domains, this would make CaCl2 linear. It has a linear structure. So some history. Calcium chloride was initially discovered in the 15th century by an unknown person because records were kind of hard to keep back then. But in 1808, it was thoroughly studied and then was isolated by the man on the left, the English chemist named Humphrey Davy. Today, it's most commonly made by extracting it from limestone deposits with the Solvay and hydrochloric acid methods. The Solvay method involves reacting limestone with salt brine, and the HCl method involves reacting limestone with hydrochloric acid. Some properties of calcium chloride, some physical properties. It's a solid white powder at room temperature. It has a melting point of 772 degrees Celsius and a pretty high boiling point of 1670 degrees Celsius. And in the second picture, it's also aqueous and hygroscopic, which means that it can turn into a liquid solution when placed in water or in a humid area. Some chemical properties are that calcium chloride has a molar mass of 110.98 grams per mole. It is a pH between 8 and 9 when in solution, which means it's a basic solution. It also participates in exothermic reactions with other compounds where heat is released in this process. Some uses for calcium chloride. It can be used as a desiccant, which is a drying agent, and the FDA approves it as one of the most useful desiccants to preserve meats and refrigerated foods. It can also be used to de-ice surfaces like roads during the wintertime, and it can also be put in pools to increase the amount of chlorine in the water so that it stays clean, and it can be used to clear calcium deposits in the bloodstream too when it's aqueous. So for my reaction, I chose to use the Solvay method of making CaCl2, and just to specify how it's actually made. So it's a double replacement reaction which begins with aqueous salt brine, which is just NaCl, and solid NaCO3. And so then it's present in deposits of limestone. When the salt brine reacts with the NaCO3, they switch cations, and then it forms sodium carbonate in a solid form, which is also called soda ash, and it also forms CaCl2, which is calcium chloride, which is partly crystallized, and then the two of them can be separated from each other later when the reaction is complete. Some interesting facts about calcium chloride. When it was first discovered in the 15th century, it was seen as a waste product until Humphrey Davy isolated it. So it was kind of just seen as waste that occurred in every other reaction. And another interesting fact is even though it can be injected into the bloodstream, it can have a lot of side effects like nausea, or vomiting, or loss of motor functions in really severe cases. But this only commonly happens when too much of it is used. And a third interesting fact is that in 1953, by accident, somebody made calcium 1 chloride, which is just CaCl, but it turned out to be a really unstable gas, and it dissolved into the air in seconds. And since then, there have been several attempts to recreate it, but so far nothing has turned up. And that's the end of my presentation.